Hello there, this is an Algebra 2 video, and it is Chapter 6, Section 1, and if I could just get back to the first slide here, that'll become clear. And today we're talking about operations on functions, and just like you can add, subtract, multiply, and divide numbers, you can also add, subtract, multiply, and divide functions. So, we're going to do addition and subtraction first, and then we will progress to multiplication, division, and even one called composition. So, addition. First of all, I just kind of wanted to make sure that you understand the notation. A lot of times what the book is going to do is give you this kind of notation, the first portion of it, which this is basically in parentheses f plus g. And this just is like f plus g of x. So when you read this, you say f of x, and you're pretty comfortable with that by now. But when you have this, just know that it's f plus g of x. And literally it means to take the f of x function and add it to the g of x function. And likewise, you have f minus g of x, and that literally means to take the f of x function and subtract the g of x function. So we're going to do that. In this example, it says, given that f of x equals x squared minus 4, and that g of x equals 2x plus 1, find each function and then indicate any restrictions of the domain and range. When you are composing functions, the domain and range is going to be based on the original functions themselves and then the composed function. So, or not the composed, but then the function that is put together. So, in other words, when I look at f of x equals x squared minus 4, this function is a quadratic, it's a well-behaved function. The domain is all reals. There are no issues of domain. As far as the range, there is x squared minus 4 is a parabola that opens up, and its vertex is at -4. So it means that the range is going to start at -4 and then on up. In the case of g of x, the domain is all reals, the range is all reals. So because of that, when I put the two functions together, their domain is going to be affected by both functions. So first I want to find the function. So like I said before, it's a lot easier if we basically rewrite f plus g of x into the notation of f of x, which is x squared minus 4. That's the f function. And add it to the g function, which is 2x plus 1. There's not necessarily a need for the parentheses. I'm just showing you that that's the entire function. When you're adding the two functions together, all you want to do at that point is combine any like terms. So we have x squared from here, plus 2x from there. And then we want to combine the like terms, -4 and +1. And -4 and +1 is -3. So this becomes my f plus g of x function. Now because both original functions had domains that were all reals, then the addition of the two functions also has a domain of all reals. So we're going to move on to f minus g of x. And this one, it's not trickier. It's just that a lot of times students will forget the negative part. So that's just the only thing that I want you to be careful with. So the f of x function again is x squared minus 4. And then we subtract the g of x function, which is 2x plus 1. And see, in the case of addition, the parentheses were unnecessary because when you're adding, you don't have to distribute anything. You just add them together. But when you're subtracting, you definitely have to distribute this negative. And that's what students generally forget to do. So I want you to just be careful with that. But we're going to get x squared minus 4, and then we're going to have minus 2x. Excuse me. And then negative times +1 is -1. So over there we had plus 2x plus 1. Now we're going to have minus 2x minus 1. And again, we're just going to combine our like terms. So we get x squared, we have a -2x. And this time we have -4 and a -1, which makes -5. And so this represents f minus g of x. All right, and again, same idea with domain. The domain is going to be all reals because the domain of the original functions was all reals. So now we're going to have you try this do-it-yourself number 1, and then we'll move on to multiplication and division. And again, we want to begin with the notation. we have the little multiplication dot here, so f times g of x, which literally means to multiply the f of x function by the g of x function. And then f divided by g of x literally means to take the f of x function and divide it by the g of x function. And because you're dividing, this is where the domain does become an issue, but whenever you're dividing by a polynomial, you want to make sure that the bottom is not equal to 0. You can't divide by 0, so we want to make sure that g of x is not equal to 0. So we have an example here. This time my function is x squared plus 7x plus 2. So I need to take f of x and multiply it by the g of x function, which in this case is going to be x squared plus 7x plus 12. And I'm going to multiply that by the g of x function, which is 3x minus 4, which is going to require that I take and I'm going to go from the left here. So it's going to be 3x times x squared plus 7x plus 12. And then we're going to subtract 4 times x squared plus 7x plus 12. So basically, you don't have to do it the way that I'm doing it. You could go x squared times 3x, x squared times negative 4, but I just think that it's easier to do two terms and multiply by the entire polynomial. So that's just kind of what I did there. So in the first case, we're going to get 3x cubed plus 21x squared plus 36x. And then we're going to get negative 4 times x squared is negative 4x squared. I'm going to put that right underneath the like terms here. And then negative 4 times positive 7 is negative 28x. And then negative 4 times 12 is negative 48. So now I can add up my like terms, and I'm going to get 3x cubed, and 21 minus 4, is going to be 17 x squared, and then 36 minus 28 is going to be 8 minus 48. So f times g of x is going to equal 3x cubed plus 17x squared plus 8x minus 48. Now for the division one, and the domain here for that guy, again, the domain of the original two functions is all reals, and the domain of the resulting function is also all reals. But that's going to be a little different when we come to part B, which literally means f of x divided by g of x. In some ways, this is a lot easier, because in that case, there's so much work to be done to simplify your result. But in the case of the division ones, you generally don't have to do a lot of simplifying. The hard part comes from the domain issue. So f of x is basically the x squared plus 7x plus 12, and you're dividing that by 3x minus 4. And you're not going to try to cancel it. You know, if it factors, you can try to factor it, but I can tell you right now that there's not going to be any factor on the top that's going to be 3x minus. The only reason why I would try to factor it is to see if I could cancel anything. So let me just show you what I mean by that. Because this is a 1x squared, the factors are going to have 1 and 1. There's not going to be a 3. And for 12, you can do 4 times 3 like this, and 3 plus 4 is going to be the 7. So if I were to factor this, it would be x plus 4 and x plus 3. But neither of these factors has a 3x in it, which would cancel with the 3x in the bottom. So basically, the factoring isn't going to help. So you don't need to factor it. And that's why in some ways this is actually a lot easier of a function to do, because you just have to just put it in there like this divided by that. But the part that does get crazy is the restrictions. When it says to list any restrictions, we definitely don't want the bottom to equal 0. So we're going to say 3x minus 4 equals 0. I need to know when will the bottom equal 0. So I solve this equation, and this equation will tell me when I add 4 and divide by 3 that when x equals 4/3, this expression will equal 0. And I don't want it to equal 0. So I have to restrict my domain and say that x cannot equal 4/3. So this would be my answer. I would have the x squared plus 7x plus 12 divided by 3x minus 4, but I would have to state that x could not equal 4/3 in this case. So now I want you to try this little guy, and then we're going to move on to I'm really sorry, I didn't even tell you what to do in this example. I just noticed that. Okay, so I need to tell you what A and B are. A is actually going to be f times g of x, just like it was in the example. And B is going to be f divided by g of x. So I'm sorry about that. I didn't write that earlier. But once you do that, then we can move on to the next example, which is going to be our last example, and that is composition. Composition is probably the one that creates most havoc for people, and I'm going to try to hopefully ease that pain for you. But basically what composition is, a lot of times people call this fog. Please don't call it fog, or goff if it's backwards, like they'll read this fog and goff. It's not fog and goff. It's f of g of x or g of f of x. So basically what this is whatever the first letter is, that's the function that goes outside, and the second letter is the function that goes inside. But basically what you're doing with composition is you are putting one function inside of another. So g of x is its own function, and it's going to go inside of the f of x function. So that might sound kind of scary right now, but I kind of want to show you how this works. First, we're going to start with probably what will be the more complicated one, which is starting with a set as your function as opposed to an actual equation. And then part B will do an equation. It'll be a little bit easier. But how does this work? Okay, so basically what happens is we want to find f of g of x. F, and I hope I have enough space here, f of g of x. Okay, well that means that I have to put all of the g of x function, which is over there, inside of the f function. So in this case it kind of seems strange because we don't actually see what the functions are, but I'm going to break it down for you. When I go to the g of x function, the first element of the g of x function is this guy right here. So the input is 8, so I'm going to go g of 8. Okay, I want f of g of 8. The next element is the 5, 1, so that's going to be g of 5. The next element is 10, 14, so that's going to be g of 10. And then the last element is 9, 0, so that's going to be g of 9. Okay, so I'm looking at the x coordinates, 8, 5, 10, and 9, that are going to go into my g function in the inside. Okay, so now what I want to do is kind of rewrite this so it's a little bit easier to write. What is g of 8? What is the value of the g function when x is 8? Well, the value of the g function when x is 8 is 15. So I'm going to replace g of 8 with 15. Here I'm going to replace the g of 5. I want to know what is the value of the g function when x is 5. The value of the g function when x is 5 is 1. So I'm going to replace g of 5 with 1. Same thing here. G of 10 is, what is the value of the g function when x is 10? And when x is 10, the value of the g function is 14. So I replace g of 10 with 14. In the last one it says, what is the value of the g function when x is 9? And the value of the g function when x is 9 is 0. So I'm going to replace g of 9 with a 0, and now I'm looking for f of 0. Now it doesn't seem so hard. Now what I'm really asking is, what is f of 15? Well, now since I'm looking for the f function, I want to know what is the value of the f function when x is 15. So here's my f function, and when x is 15, the value of the function is 11. So that will be equal 11. Same thing here, I need f of 1. What is the value of the f function when x is 1? It's 8. What is the value of the f function when x is 14? It's 9. And what is the value of the f function when x is 0? 13. Okay? 11, 8, 9, 13. So now if you wanted to put them in ordered pairs, you could, because we need to answer this question. We need to write in our answer over here with ordered pairs. So the input started with the 8 from here. So when the x was 8, because you have f of g of x, right? So f of g of x. So we have our 8, and at the end of the day, the value of that function was 11. So there's your ordered pair. Your first ordered pair is going to be 8, 11. And it's going to be 5, 8. We're also going to have 10 and 9. And then we're going to have 9 and 13. Okay? So those ordered pairs are what make up the f of g of x function, which are a little bit different than what you have in f and g. Alright, so it also says take the domain and range for each function. So the domain, when you're looking at ordered pairs, is really simple. You just want to list all the x values for the domain in order from smallest to biggest, and don't repeat anything if they're repeated. So smallest to biggest, we're going to go 5, 8, 9, 10 are the different x values that we have. 5, 8, 9, 10. And for the range, same idea, only now you want the y values. We're going to go 8, 9, 11, 13. 8, 9, 11, 13. And that's basically how you do that. So we're going to do this again. Only this time I want to go backwards. Now they want us to find g of f of x. So we're going to do all the same stuff. G of f of x, but we're going to go a little bit backwards. So we're going to go g of f of, and so this time we're going to go to the f function first. So the first value of the f function is 1. So g of f of 1. We want g of f of 0. We want g of f of 15. And g of f of 14. So now we're going to do f of 1, just like we did with the other function. I want to know what is the value of the f function when x is 1. The value of the f function when x is 1 is 8. So I'm going to replace the f of 1 with 8. F of 0 means what is the value of the f function when x is 0. The value of the f function when x is 0 is 13. So I'm going to replace f of 0 with 13. The value of the f function when x is 15 is 11. So I'm going to replace f of 15 with 11. The value of the f function when x is 14 is 9. So I'm going to replace f of 14 with 9 and get this. So we have g of 8, g of 13, g of 11, and g of 9. So now g of 8 is what is the value of the g function when x is 8? 15. What is the value of the g function when x is 13? There is no 13 in the domain of g. So this value is undefined in this function. Same thing here, g of 11. 11 is not in the domain of the g function. So it's also an undefined value. And then lastly, g of 9, the value of the g function when x is 9 is 0. Alright, so the ordered pair that we end up with, to write our answer in over here, the ordered pair we're going to end up with is just the 1 and the 15, and the 14 and the 0. So we only have 2 ordered pairs in this function's composition. So then for the domain, you only want the x coordinates, smallest to biggest. So we're going to go 1, 14. And for the range of this function, you're going to have the y values 0 and 15. And that's it. So that is how you do it when you have a set of numbers like this, a set of ordered pairs. And now we're going to show you how to do it when you have an actual function. Alrighty, so again we want f of g of x. So they want us to find f of g of x, which literally means f of g of x. And they also want us to find g of f of x, which literally means g of f of x, like that. So what I like to do is very similar to what we did earlier, is we want to put the g of x function completely inside the f function. Well, we know what the g of x function is. G of x equals 4a. So what we could do is, instead of writing f of g of x, we could write f of, and replace the g of x with what it equals, which is 4a. All right, and then what we do is we go to we want to know what is the value of the f function when the x is 4a. So we want to come over here, and actually I'm already noticing some issues right now with my notation here. My bad, I get so used to using x all the time that the actual problem should never have an x here and a there. They should have the same variable. So both of those should either be a's or x's, but they can't be one of each. So we want to go and call this x, I guess. Let me fix that for you here. So we're going to go ahead and just call it x. So it's going to be 2x minus 5, I believe it was, and 4x for our two functions. So then over here, I'm not going to plug in 4a, I'm going to plug in 4x. Nice, okay. So I replaced the g of x with what it equals, which is 4x, and so now there's a 4x in there. So now I want to go, what is the value of the f function when the x value is replaced by 4x? So for that I go to the f function, and I write 2x minus 5. I use parentheses for that. I want to remind myself that I'm going to put something inside there. And what I'm going to put inside there is what is inside the parentheses here. So I'm going to put a 4x there. And then I'm going to simplify. 2 times 4 is 8x. And then minus the 5. So it turns out that f of g of x is equal to 8x minus 5. So see, I think that in most cases, most people will think that this is simpler than what we just finished doing earlier. But, you know, it's up to you to determine which one you like better. So over here, I'm going to do it backwards, g of f of x, but it's going to be a lot of the same scenario. So what we want to do is g of the f of x function. Well, what is the f of x function? The f of x function is 2x minus 5. So again, I'm going to replace f of x with what it equals, which is 2x minus 5. So I replaced it in there. And then the g function is 4 times x. And again, I use parentheses to indicate that this is where the x goes, but that's where the input goes. But right now my input is 2x minus 5. So I'm going to put the 2x minus 5 where my x would be. And then I'm just going to simplify my answer. And I'm going to get 4 times 2 is 8x, and 4 times negative 5 is negative 20. So although the functions are very similar, they're not the same. The g of f of x function ends up being 8x minus 20, and the f of g of x function ends up being 8x minus 5. So they do have the same 8, but they have different y-intercepts. So that is how you find a composition of functions. And so now I'm going to let you try the same thing we did. We're going to start first with one that has the ordered pairs as the functions. And then you'll do one that has actual equations as functions. And once you have completed your notes for this lesson, or for this problem, sorry, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.